Alright, so this video is going to talk about the algebra that's necessary for this class. As I discussed in the welcome video to the course, physics relies on mathematics a great deal. In fact, the deeper you get into physics, and pretty much any other scientific topic, the more mathematics you're going to be using. Math is a very powerful language and set of tools that allows you to answer questions, figure out complicated ideas, model systems to try to kind of tell the future, figure out what's going to happen based on the information you know now. Well, one of the big parts of math you definitely need to know for this course is algebra. And I know everybody's had algebra in high school and somewhat in college as well. And it may have been a while since you've really concentrated a lot on algebra, but this video is to try to review the major aspects of algebra we're going to have to understand in order to do well in this course. We're not going to need to know every aspect of algebra, every little tip or formula or anything like that. There's certain bits of algebra we need to know, and because they're going to be used very often. And the more you practice them now, the more comfortable you're going to feel. That way, when you get into the physics aspect of this course, you won't have to concentrate and worry so much about the math aspect. You're just going to use the math to get what you desire out of the physics. So the first bit of algebra is just the plain old, do you know how to solve an algebraic equation? And so something like this. Let's say we have 4x plus 2 equals 10. So of course this is an algebra equation. There's an unknown, the variable x. That's the thing I want to find out. This is basically saying if I take the number x and I multiply by 4 and then I add 2 to that thing, then I get 10 as a result. And so I want to know, what must that thing be? Well, I believe we all remember how to solve a problem like this. The first thing you do is the term which has the variable, you have to leave it alone at first. Eventually what you're going to want to do is have one side of the equation have the variable by itself, and the other side of the equation has the answer. And so we're going to manipulate this equation, moving terms around using certain rules, such that I get a final equation that looks something like x equals something. That's what I want. So, what are the rules? Well, I already stated one rule, the term which has the variable associated with it, that is this 4x. I can't move that yet. I have to leave it alone. Whatever is not associated with the variable, so this plus 2, that I can move because it's not held on to by the variable. So, if we remember the rule says if you have plus a number and you want to move it to the other side, then you do the opposite operation. So this is adding 2, so in order to get rid of it, I subtract 2. So I subtract 2 on that side, which means I also have to subtract 2 on the other side. And whatever you do to one side of the equation, you have to match it on the other side of the equation for the equation to remain the same. So when I do that, notice the plus 2 and the minus 2 cancel, and I'm left with 4x equals 10 minus 2 is 8. Alright, now I'm close. What I've done is I've left one side of the equation has a term with the variable and nothing else, and the other side of the equation has a number. Good. The problem is the term with the variable still has a number on it, the 4. I don't want the 4 there. So now I have to get rid of the 4 to leave the variable by itself. Well, again, I use the same rule. This is saying I'm multiplying by 4. So to get rid of it, I have to do the opposite operation, which means I have to divide by 4. And what that'll do is it'll cancel the 4s. But in order to do it to that side, I have to do it to this side as well. And so what's left? X equals 8 divided by 4 is 2. And there's my answer. Now that's the formal mathematical way of solving this equation. These are the rules you learn when you take algebra in high school, how to manipulate the equation. You start with the terms which do not have the variable and you move them over. And then you're left with the terms with the variable, and in order to mess with that, you again do the opposite operation to bring it to the other side. Now, one thing I'm going to say is you really need to get very comfortable with this, so comfortable that you don't think about doing this equation the way I just did it. In fact, for me to explain what I did to solve this equation was kind of difficult for me because I don't think about doing it the way I just said it. Even though that's the rules you learn, eventually you come to see the equation a little bit differently. So let me show you what I think about when I'm solving this equation. Let's start with the 4x plus 2 equals 10. Now, I still want to do the same thing. I still want to be left with the x on one side. And I remember the rules. I don't mess with the 4x part. I have to mess with the plus 2 because that's adding or subtracting. I could do those first. And then the multiplying and dividing I can do last. However, for me, what I'm thinking about is this 2, I want to move it to the other side to get x by itself. And so I'm going to move the 2 to the other side. So what that means is I'm going to be left with 4x on this side. And over here, when I move the 2 over, because it was plus 2, it's now minus 2 on this side. So 4x equals 8. And now again, one side of the equation has a term with x. That's good, but it has the 4 sitting there. So I want to bring the 4 to the other side. So in order to bring the 4 to the other side, I divide by 4. That's the operation to get rid of the 4. So this becomes x equals 8 over 4, which is 2. So it's a very subtle difference between the formal mathematical way, which is on the left, and kind of the street rules method that you eventually start to see when you're doing these equations. Now, you don't really see too big of a difference. In fact, everything I did on the left, I did on the right, but it was more about how I thought about it. I'm not thinking about I subtract 2 to the left, and then I have to subtract 2 to the right, and then I'm left over with this, and then on the left I'm going to divide by 4, that cancels the 4, so on the right I have to divide by 4. I'm not thinking that in my head. I'm thinking move things from one side of the equation to the other side of the equation. The rules are the same, but the thought process is subtly different. And what we're going to find later on, when we don't have so many numbers in our equation and everything's variables, it's easier to understand solving an equation like that when you're thinking about it as moving terms around rather than adding things and subtracting things to cancel. If you're not at that point yet, don't worry. The practice you're going to be doing in this stuff will help you get there. But that's the goal I want you to be able to reach over some time, is to think less formally about the algebra and more about, oh, I'm manipulating the equation. I'm going to bring this term from the left to the right to be left with whatever it is I want to find. So that's your normal algebra. You have one variable, and you're trying to solve for that unknown variable, and everything else is a bunch of numbers. Of course, there's also what's called quadratic equations. And quadratic equations are those which include the variable to the second power. So for instance, you may get an equation that looks something like this. X squared plus 3 equals 12. So this is very similar to the previous equation we had. We have an unknown variable, we have a bunch of numbers. And now what I want to do is solve for the unknown variable x. So I'm going to start the same way. I want to leave the x alone. I want to get him by himself, so everything else I want to move to the other side. So I'm going to bring the 3 over. I'm doing it in the long way for now, just until we're used to this stuff. Bring the 3 over to the other side. I'm left with x squared equals 12 minus 3, which is 9. And now here's the difference between a quadratic type equation and a regular algebra equation. I don't have a term that says x equals a number. I have x squared equals a number. And so it's fairly easy to answer this. All you need to know is when you have a squared variable, you have to take the square root to get the answer. So, okay, no problem. Take the square root of the left side, which means I have to take the square root of the right side. So when you do that, the square root cancels the squared, and so you're left with x on the left, and on the right, you get, what's the square root of 9? Square root of 9 happens to be 3. However, there's another piece of formal mathematics we have to remember, and that is, when you take the square root step, this step right here, you have to include the fact that the answer can be plus that number or minus that number. So it could be plus 3 or it could also be minus 3. They're both legal answers. So there we go. The answer, what number when plugged in for x will make this equation true? Well, I can plug in plus 3. Let's see what happens when I do that. I get 3 squared plus 3. 3 squared, that's 9, plus 3, which equals 12. And what happens if I plug in the minus 3? Well, minus 3 is squared, plus 3. Minus 3 times minus 3 is plus 9, plus 3, which equals 12. So you can see they both work. So both are legal answers. And this is true anytime you have an equation where the variable is raised to a power. Here they're raised to 2. When you have an equation where the variable is raised to a power, the number of answers to that equation is equal to the highest power of the variable. So that means in this case, x squared is the highest power, 2. That means we're going to get 2 answers to this equation. If I had something like x to the 4th plus 5x squared plus 3 equals 10, the 4th is the highest power. That means there's going to be 4 answers to this equation. So that's just something to note. It's important at some points because what this means is if this equation was related to a physical formula, an equation, and I'm trying to solve a problem, the problem might be where is the rock going to be when it collides with the tree or something like that. And you get an answer of plus 3 and minus 3. Well, that means the rock could be 3 meters above the ground, but it could also be 3 meters below the ground. Both times it would be colliding with the tree. So they're both real answers. Now, sometimes mathematically you'll get 2 answers, but in physics only one of them really makes sense. For instance, for the rock to go under the ground to hit the tree doesn't make physical sense, so we would just throw that answer away and only keep the positive answer. That's something we do because we're physicists, we're not mathematicians. The math people would say they're both real answers, so I have to keep them both. The physicists are saying, yes, they're both answers to the math equation. However, we're looking at a physical problem, and there are certain rules of physics which math doesn't deal with. But anyway, that's all there is to this type of problem. You have an equation where the variable is squared. Well, no big deal. You're going to be using the square root. However, There are other types of quadratic equations that are not so straightforward. For instance, let's say I have something more like x squared minus 4x minus 1 equals 4. Now obviously, this equation is different from the top equation because the top equation had an x squared but no other terms with x in it. This new equation has an x squared term and a linear term, an x term as well. That makes this a true quadratic equation, and there's a certain formal way of being able to solve something like this. We cannot use the little square root trick we did upstairs because of this term right here. That doesn't allow us to do it anymore. So how does one solve a quadratic equation? Like this, where there's an x squared, and a number. The first thing to do is you want to get this into what's called standard form. And standard form looks like this. ax squared plus bx plus c equals 0. Where a, b, and c are just numbers. So we need to make this equation look like that equation. All right, well, so far it looks okay. X squared, there's a 1 in front of it, so a would be 1. The x term, there's a minus 4, so b would be minus 4. C is minus 1 here. However, it's not equal to 0, it's equal to 4. That's bad. We have to let it equal 0 on the right. So the first thing I'm going to do is I'm going to move the 4 over to the left side. How do I move it? Well, right now it's plus 4, so I bring it over as a minus 4. So now our equation, x squared minus 4x. Now I have minus 1, and I'm subtracting a 4 over, so minus 1 minus 4 is minus 5, equals 0. This is our equation we have to solve. We now have our quadratic equation in standard form. Now, there are two ways to be able to solve a quadratic equation in standard form. At least there's two ways you learn in a math class, in algebra. The first way is to try to factor into two binomials, something like this, if you remember. Some, I don't know, dx plus e fx plus g equals 0 type thing. And try to figure out what must be all the numbers in these two binomials. And that may be possible. If you remember in algebra class, sometimes it was. We could look at this and see if it's possible. And in fact, let's go ahead and do it on this next page just so we have some room. The equation was x squared minus 4x minus 5 equals 0. And if you remember factoring, the rule was, hey, let's look at this number here and look at this number here. What we need to do is to factor into two terms and to say, okay, because this number here has a negative, that means one of these is going to be a plus and one's going to be a minus. They have opposite signs. And then a rule said you need to choose numbers to go here and here such that when they multiply together, it gives you the minus 5. But when you add them together, you get this minus 4. And if you think about it for a little bit, it turns out that you could put a minus 5 here and a plus 1 here. And then we could test to see if this is true. We multiply these binomials together, you get x squared minus 5x plus 1x minus 5 equals 0, which is x squared minus 4x minus 5 equals 0, which is what we have here. So yes, this is the answer. Well, it's almost the answer, I should say. The true answer is what values for x makes this thing true. So actually, let me go ahead and get rid of this box because... Alright. So no more box because that's not our real answer. What we have to do now is use these two terms and say, okay, if this term times this term is equal to 0, then what must this term be and this term be? Here's how we can think about it. This is a very nice way of thinking about things like this. Forget x plus 1 and x minus 5. Just pretend I have a times b is equal to 0. And then think, okay, what must a be and what must b be in order for this to be true? Well, the only way two numbers multiplied by each other can be 0 is either a equals 0, b equals 0, or both a and b equals 0. Right? If this is 2 times 3, you're not going to get 0. Either a has to be a 0 and b can be anything, or b is a 0 and a can be anything. So we do the same thing here. X plus 1, that's like our a, so either x plus 1 is equal to 0, or x minus 5 is equal to 0. And so we look at each one individually. We say, okay, x plus 1 is equal to 0. When is this true? I bring the 1 over to the other side. That's true when x is equal to negative 1. What about the other one, x minus 5? X minus 5 is equal to 0. When is this true? Well, it's true if I bring the 5 over to the other side. It becomes plus 5. X equals plus 5. And so now I have my two answers. X is either 5 or minus 1. So that's how you can answer this question factoring. Once you're able to go from this step to this step, the rest is really easy. You just take this binomial on the left, set it equal to 0, and solve for x. And then you take this other binomial on the right, set it equal to 0, and solve it for x. And then you get your two answers. Again, we should get two answers because it's x squared in the problem. 2 is the highest power, thus you should get two answers. Here's the dilemma. The problem is finding these two numbers here is not always possible. Trying to get the two binomials sometimes is not possible to do. It happened to be possible here because, of course, when the equation was made, when the problem was made, the numbers were chosen, so they were very nice numbers that worked out. But what happens if you're given numbers that don't work out? What if you can't find the binomials? Thankfully, there's a different way of solving it that always works. And in fact, what I'm going to suggest to you is don't worry about trying to factor like this as you did in algebra class. Forget that. Always do this other thing because it will always work, and you don't have to put so much time into thinking about which numbers will work and which ones won't. So again, let's start with the equation. X squared minus 4x minus 5 is equal to 0. And here's the second method, and that is the quadratic formula. The quadratic formula says if you plug in the numbers to this formula, you will automatically get the answers for that equation. First thing to do to use the quadratic formula is you must get your equation into the standard form. So again, the standard form was ax squared plus bx plus c is equal to 0. Once it's in standard form, then go ahead and figure out what is your a, what is your b, and what is your c. So for us, our a is the term in front of the x squared, that's plus 1. Our b, that's the term in front of the x, that's minus 4. You have to include the sign. And our c, that's the term in front, or without the x at all, that's minus 5. Once you have your a, b, and c, now you use the quadratic formula, which says the answer to your question, x, is equal to b squared plus or minus the square root. I'm sorry, not b squared. What am I thinking? Minus b plus or minus square root of b squared minus 4 times a times c, all divided by 2a. Where a, b, and c are these numbers you found over here. Notice this little piece right here, this plus or minus, that means this really is two different equations. The first one, minus b plus the square root of b squared minus 4ac over 2a. And the other one is minus b minus the square root of b squared minus 4ac over 2a. So I'm going to get two answers, one where I use the plus and one where I use the minus, which is what I'm wanting. I do want two answers. All right, so let's go ahead and plug in our numbers. Minus b, well, b was negative 4, so this is minus negative 4 plus square root of b squared, so minus 4, the whole thing gets squared, minus 4 times a, which is 1, times c, which is minus 5. Everything's divided by 2 times a. 2 times 1 is just 2. Our other one, again, minus negative 4 minus the square root of negative 4 squared minus 4 times 1 times negative 5, all divided by 2. All right, so now it's just a matter of plugging this into your calculator or doing it in your head, however you want to do it. Let's look at the square root part first. All right, so we have negative 4, that's positive 4, plus square root of. Negative 4 squared, negative 4 times negative 4 is 16. Minus 4 times 1 times negative 5. 4 times 1 is 4. 4 times negative 5 is negative 20. So it's 16 minus negative 20, which means it's 16 plus 20, divided by 2. And this one over here is going to look the same, except it's minus 16 plus 20 over 2. All right, that's not bad. This is 4 plus square root of 16 plus 20 is 36. The square root of 36 is just 6. And divided by 2 is left. And over here it's 4 minus the square root of 36 is 6 over 2. All right, well, 4 plus 6 is 10 over 2, which is 5. So there's one answer. 4 minus 6 is negative 2 over 2, which is minus 1. There's our second answer. So this tells us x is either plus 5 or negative 1. And if you remember from before, that's what we got over here when we factored. So same answers. So that's our quadratic formula method. The good thing about the quadratic formula is, unlike factoring, where you have to do this step, where you have to try to use these numbers in your original problem to try to figure out what you could plug in for the binomials, here you don't have to do any of that. You're given an equation, a formula to use. You look at the problem that tells you these a, b's, and c's, and all you do is plug the a, b's, and c's in to this formula. From there, all it is a bunch of numbers. You're adding together, subtracting, multiplying, whatever. You can plug it into your calculator. You're going to get one answer with the plus. You're going to get one answer with the minus. And both answers solve your equation. My tip to you is, if you see a quadratic equation that you have to solve, automatically solve it using quadratic formula. Don't try factoring first. It's going to be a waste of time, because even if you can factor it, it actually takes longer than if you were to just do quadratic formula from the beginning. Now, remember, this is true when you have all three of these terms, an x squared term, an x term, and a linear term, just a number. If you remember over here, we had an x squared term and we had a linear term, but we did not have the x term. So this was not quadratic formula. And in fact, there's another thing which looks similar. You can have something that looks like this. 4x squared minus 8x equals 0. So you say, oh, well, look, there's an x squared, there's an x. Is this a quadratic equation? No, it's not, because it does not have the c. It does not have the plus c term. So I don't have to use quadratic formula to solve this. What I can do is I can factor this. This is an easy factor. To factor this, we just say, look, this term has an x on it, and this term has an x on it. Everything on the left has an x. So factor out an x, and when you factor it out, what's left over? Well, I still have a 4 and an extra x on the left term. And then on the right term, the x is now gone. All I have left is this 8. So to go from here to here, all I did was factor out an x, because they both had an x on it. Now, for those of you that are keeping up, you can also see both terms have a factor of 4 associated. So I could have also factored out a 4. In this case, I'm just doing one little step at a time to make sure everybody's keeping up with me. But if you want to factor out a 4 as well, you can do that. But anyway, once we get to this step, how do we answer the question? Well, it's the same thing I said before. Some term times another term equals 0 means either A is 0 or B is 0 or both. So either this x is equal to 0, in which case it says x equals 0, or this term is equal to 0, which says 4x minus 8 is equal to 0. If this 4x minus 8 is equal to 0, well, I bring the 8 to the other side, so that becomes 4x equals 8. And I bring the 4 to the other side, so that says x is equal to 8 over 4, which is 2. And now I have my two answers. X is equal to 0 or 2. So that was quick. I did not have to use quadratic formula because I did not have a quadratic equation. I was missing the c term. So this one's done by factoring. So when you're given a problem and you have your equation sitting there, you have to be able to look at the equation and tell, first of all, is it just a normal linear algebraic equation? Or is it quadratic? If it's quadratic, do I have to use a quadratic formula? That is, when I put it into standard form, does it have the a term, the b term, and the c term? If it has all three, use quadratic formula. If it doesn't have all three, then there's some other method. You could either factor like this one, or in a previous problem over here, this one here, I just had to use a square root. And you'll see the more problems we solve, the more comfortable you'll get, and the quicker you'll be able to decide what type of problem we have. Now I have one last aspect of algebra you need to understand or be able to do, and this aspect is systems of equations. So this happens when you have two unknowns sitting in your problem. So maybe you're given a physics problem where someone's standing on a cliff and someone's at the bottom of the cliff, and they both throw a rock at each other, and you want to know when will the two rocks collide and how high up will they collide. So you have two different unknown pieces of information. You don't know where they hit, and you don't know when they hit. So you have two unknowns. Well, in order to solve a problem like that, you must have at least two equations. Because we know we cannot solve a problem that looks something like this, x plus 3y equals 1. We can't solve this algebraically. There's too many unknowns. There's an x and there's a y. We don't know either. And the only way to be able to solve a problem that has two unknowns is to have two different equations with those unknowns in them. So let's take a look at how do we solve a problem that does have two equations with two unknowns. So let's take a problem like this. 4x minus y equals 5. And then another equation says negative x plus 3y equals 7. So again, x and y, they may stand for position and time, or the x direction and the y direction. I don't know what they mean currently. This is just a practice problem. But there are two pieces of information I want. At the end of the day, I want to have something that says x equals blah, 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 and y equals blah, blah, blah. So how do I go about doing it? There's different ways, and in fact, in algebra class, I'm sure the teacher showed different ways of being able to do this. I'm going to show you the way I usually handle these problems, because for me, it's the easiest way to do it, the least amount of thinking involved. If you're used to a different way of doing it, and it's correct, by all means, do it that way. That's fine with me. What I'm going to do is called substitution. And the substitution method says, take one of the equations. So let's say I take the first one, 4x minus y equals 5. So take one of those equations and solve it for one of the unknowns. So that is, I'm taking the first equation, and I'm either going to solve for x or I'm going to solve for y. Looking at it, it's probably easier to solve for y. So how am I going to solve this one for y? Well, y has a negative on it, so if I bring it to the other side, it'll become positive. So 4x equals 5 plus y. Okay, but again, I want to get y by itself, so I need to bring the 5 over to the other side. So now it becomes 4x minus 5 equals y. And there we go. I've solved one of the equations for one of the unknowns, for the y. If I happen to know the value of x, then I would have an answer for y. I'd have a number. But I don't have that value yet. The second step of substitution says, once you've found one of the unknowns in one of the equations, plug that thing into the second equation. So now I'm going to take the second equation, minus x plus 3y equals 7, and everywhere I see a y, I'm going to plug this thing into it. Because I know y is this thing, and anywhere I see a y, it's that. So when I plug all of that stuff in for this y here, I get minus x plus 3 times y, it turns out, is 4x minus 5 equals 7. And now look at what we're left with. Here we have a single equation, and how many unknowns are there? There's only one unknown sitting there. X is the only unknown. Y is completely disappeared. This is good. You can solve an equation with only one unknown in it. So let's do it. Minus x plus. Now, I don't like this little binomial thing here, or this factoring thing. So I'm going to do what's called distributing. I'm going to multiply the 3 in for both terms. And when I do that, 3 times 4x, that's 12x. And then 3 times negative 5 is negative 15. Okay, so this little factoring thing here becomes these two terms here. Now I collect all the like terms together. So I have a negative x and a 12x. That becomes 11x minus 15 equals 7. Again, I want to solve this for x, so I want to get the x term by itself. So the first thing I'm going to do is bring the 15 over to that side. So 11x equals 7 plus 15 is 22. Then I want to get x by itself, so I'm going to divide by the 11, and I get x is equal to 2. I now have a value of x. X is 2. I'm halfway done. I have one of my two answers. How do I get the other answer? The last step of substitution says, once you have one of the answers, plug that back into the original to get the first. So here we have an x in the first equation we started with. So we'll say, okay, 4 times x, which is 2, minus 5 is equal to y. So 8 minus 5 is equal to y. That tells me y is 3. And now I have my second answer. Now I'm done. What is the value of x and y? X is equal to 2, y is equal to 3. And I've solved this problem. We can check. We can say, okay, does this work? Well, if I plug 2 and 3 here, what do I get? 4 times 2 is 8, minus 3 is equal to 5, which indeed it does. And if I put the 2 and the 3 in here, I get minus 2 plus 9. 9 minus 2 is 7, and yes, that matches the 7. So it works. This is a substitution method. It's very straightforward, very little thinking is involved. And the steps say, first, choose one of the equations. It doesn't matter which one you choose. I happen to choose the first one, but you could have chosen the second one to start with. It doesn't matter. Once you've chosen that equation, pick one of the unknowns to solve for. In this case, I chose the first equation and I chose to solve for y. Then solve it for y. Everything else just keep as a number. That x, just leave it alone as an x. Put everything on one side, y by itself. Once you have that, go to the second equation, the equation you did not use. Start with that equation, and everywhere you see the term you just solved for, so for me I solved for y, everywhere I see a y, I plug in what I found. If you had solved for x originally, then everywhere you see an x, plug in what you solved for, obviously. Once you do that, then you just mess with that equation, because basically what you have is a simple algebraic equation for one unknown. Solve for that unknown, and you now have one of your answers. To get the last answer, plug that answer back into the original thing you were looking at, and you'll get your final answer. That's how you do systems of equations. You can have systems of 3 equations, or 4 equations, or 5 equations, and so forth. They just take longer to do, but you do the same type of thing. You start with one equation and one unknown. Solve for it. Plug that into the next equation. Whittle that down, solve for an unknown. Plug that into the third equation and whittle it down. And you keep going until you use them all. Once you're on the last one, you'll get a number. That's the answer to one of your unknowns. And then you start going backwards all the way back to get the rest of them. So this is algebra. This is the type of algebra you're going to need to know. Obviously, this is a lot all at once, and if you're not used to algebra stuff, it may take a little practice to refresh your mind. That's the point of this. That's why we're starting with this review now, before I do any of the physics. I will be posting the AlgbraReview practice problems for you to work on, and I will also post a little review guide worksheet type thing for you to turn in, but I will send more information about that when that's sent on Canvas. So be sure to look on Canvas for the practice problems. And if you have any questions, feel free to email me. But I wish you luck.